Welcome back to the deep dive. And I have to admit, when I first looked at the stack for this week, I I sort of sighed.
You sighed. That's, not the energy we usually start with.
I did. I really did. Because I saw AI, I saw LLMs, and I saw yet another white paper promising to, revolutionize everything. And frankly, I have chatbot fatigue. I think a lot of people do.
Oh, absolutely. The novelty is worn off.
It's completely worn off. We've spent, 2 years now watching bots write mediocre poetry and just completely hallucinate historical facts. I was ready to just archive this and move on to something else.
But you didn't. Something stopped you.
I didn't, because I started reading the abstract of this paper, B.R.A.I.D, and a specific number just jumped out at me. It actually stopped me cold.
Let me guess. The efficiency metric.
The efficiency metric. They weren't talking about a 10% improvement or slightly faster. They were talking about a 122x reduction in cost.
It's a staggering number. It feels like a typo when you first see it.
It really does. And then right after that, I saw the claim that they could take a, quote, dumb AI model, something cheap and tiny, and make it outperform the smartest supercomputers on the planet, not by making it smarter, but just by changing how it organizes its thoughts.
And that's the moment you realize what this is really about.
Exactly. That's when I realized this is not a story about chatbots.
No. It's a story about the Industrial Revolution of Intelligence. We're moving from what I'd call the artisan phase, where we marvel at a single handcrafted AI response.
Right, like a beautiful hand-carved piece of furniture.
Precisely. We're moving from that to the industrial phase, where what matters is reliability, scale, and most importantly, cost. Can you produce intelligence cheaply and predictably millions of times a day?
So we are putting the hype aside today. We're going to dig into a stack that includes a very dense academic paper from OpenServ Labs. It's titled B.R.A.I.D, Bounded Reasoning for Autonomous Inference and Decisions.
And it's authored by their CTO, Armagan, Amcalar, and a name we should really pay attention to, Dr. Eyup, Cinar.
We've also got some of their internal manifestos, these documents about the AI workforce and AI employees, which is a whole other rabbit hole. And of course, summaries of their ecosystem, the SERV token, and recent updates.
I just want to double-click on Dr. Cinar for a second. His involvement is, to me, the key signal here. He's ex-NVIDIA.
Why is that so important?
Because when you see NVIDIA DNA in a research paper, you know they are not worried about writing better poems. They are obsessed with performance per watt and performance per dollar. It's a hardware mindset. It's about efficiency, not just capability.
That makes perfect sense. They're trying to get more out of this silicon.
Or in this case, more out of the model for less cost.
So our mission for this deep dive is to figure out if this is actually real. Can you really replace $1 million AI brain with a $10 flowchart? And if you can, what on earth happens to the global economy?
That is, without a doubt, the question of the decade.
All right, let's get into the weeds. But before we talk about the solution, this B.R.A.I.D framework, we have to spend some time on the problem. Because I think a lot of people, and I include myself in this, just assume AI is on this unstoppable upward trajectory. We see GPT-4, then GPT-5, the number goes up, so the smarts go up.
And the cost goes up exponentially.
Right. But you're saying there's a fundamental flaw in how these massive models are being asked to think right now.
There is. And to really understand it, we need to look under the hood. We need to see what's actually happening when you ask, say, ChatGPT a really hard question.
Okay, let's do that. So I ask it to, plan a comprehensive marketing strategy for a new startup. The first thing it usually says is something like, of course, let's think step by step. And then it produces this wall of text.
That exact phrase, let's think step by step, is a trigger. It's a prompt engineering trick to invoke something called chain of thought reasoning, or COT.
Which sounds good, right? I mean, I want it to show its work.
It sounds great on paper. You're asking the model to externalize its reasoning process. But here's the fundamental problem. The model is generating a monologue.
It's talking to itself.
It is literally writing out its thoughts in natural human language, one word after another. And you have to remember what these models are at their core. They are probabilistic. They are autocomplete on steroids. They are just guessing the next most likely word.
They aren't thinking in the way a human thinks, where we hold an abstract concept in our head and manipulate it.
Not at all. They're just predicting text. And this leads to two massive business-killing problems. The first is what the B.R.A.I.D paper brilliantly calls linguistic noise.
Linguistic noise. I love this term. It's so descriptive.
It's a perfect term. Think about that huge paragraph the AI writes for you. How much of it is just fluff? It's full of phrases like, first, it is crucial to consider the prevailing market dynamics. Or, furthermore, we must also analyze the competitive landscape.
It sounds exactly like a junior consultant trying to justify their exorbitant hourly rate.
It is exactly that. But in the world of AI, you are literally paying by the word or by the token. All those filler words, the firsts, the therefores, the it is crucials, they carried almost zero semantic density.
So they don't add any real meaning. They don't move the logic forward.
Nope. But they cost compute. They cost money. Every single one of them. So you are burning cash just to let the AI clear its throat before it says anything useful.
And it's not just the cost, is it? There's another issue with all that noise.
A much bigger one. You're clogging the context window. Every model has a finite amount of short-term memory it can hold at once.
Right, the amount of text it can see at any given moment.
Precisely. If you fill that precious memory with polite conversational filler and corporate jargon, you are literally pushing important facts and constraints out of its attention. You're making the model effectively dumber because it's forced to focus on sounding eloquent instead of being logical.
Wow. That makes so much sense. It's like trying to solve a complex physics problem while simultaneously trying to recite a Shakespearean sonnet. Your processing power is being split, and both tasks suffer.
That's a perfect analogy. And that leads directly to the second problem, which is far more dangerous for any serious business application. Reasoning drift.
Drift?
Have you ever had a conversation with a friend, where you start telling a story about a restaurant you went to last week?
Yeah, of course.
And in the story you mentioned, the waiter reminded you of your cousin. And then you start talking about your cousin, and then you remember your cousin's dog, and suddenly 10 minutes have passed, and you're passionately debating veterinary insurance prices, and you never, ever finish the story about the restaurant.
That is basically every single conversation I have after 2 beers.
That is reasoning drift, and these AIs do it constantly because it's just predicting the next word based on the previous words. If it gets a little too verbose, if it indulges in a bit too much linguistic noise, the entire probability distribution of what it might say next shifts.
It steers itself right off a logical cliff.
It completely loses the plot. It hallucinates. It forgets the original constraints of the prompt. It starts inventing facts because it's so deep down the rabbit hole of its own monologue that it can't find its way back to the original request.
So this whole chain of thought idea, this concept that we should just let the AI talk it out, is actually a massive trap.
It's a trap when what you need is reliability and predictability. If you're just chatting with an AI for fun, it's fine. If you're using it to brainstorm creative ideas, great. But if you were trying to build what OpenServ calls an AI employee, something that needs to execute a payroll run accurately at 2 a.m. while you are sleeping, you absolutely cannot afford for it to get distracted by its own internal monologue.
You can't have your automated payroll bot suddenly deciding to write a poem about the philosophical nature of currency instead of actually cutting the checks.
Precisely. And this is where the cost explosion comes in, which the paper details. They talk about the sheer expense of running models with hundreds of billions of parameters just to figure out a simple logic path through this noisy, drift-prone method.
Right. They make the point that as models get bigger, going from a GPT-4 to a hypothetical GPT-5 and beyond, the cost to think using this monologue method just goes vertical. It becomes a U-shaped curve where more smarts can lead to more drift and higher costs.
It becomes completely prohibitive for most businesses. If you want an AI to run your startup or handle all your customer support tickets or manage your supply chain logistics, you are looking at processing millions, maybe billions of tokens a day. If you're paying top dollar for every single one of those, and let me think about that, tokens, your entire business model collapses before you even launch.
It's like hiring a brilliant Nobel Prize-winning physicist to file your taxes.
And crucially, paying them by the word for their explanation.
Right. And they decide to write you a 10,000-word philosophical essay on the metaphysics of taxation instead of just filling out the 1040 form.
That is the agent reliability gap, in a nutshell. The OpenServ manifestos discuss this at length. We have things we call agents today. They work okay for very short, isolated tasks. Book me a flight from New York to London. Summarize this email for me.
Simple, one-shot commands.
Yes. But as soon as you increase the scope and the complexity, run my entire marketing campaign for the next quarter, the coordination fails. The responsibilities get blurry. The brilliant intern wanders off to write poetry.
So OpenServ's big insight here is that the solution isn't to make the intern even more brilliant. It's to give the intern a much, much better map.
Precisely. And that map is B.R.A.I.D.
B.R.A.I.D. bounded reasoning for autonomous inference and decisions.
Yeah.
It sounds very sci-fi, but when you actually break it down, the core concept is almost deceptively simple, isn't it? It's about changing the format of the thought process itself.
It's a fundamental shift in the medium of thought. It replaces the thought from unstructured text to a structured visual plan, or, to be more specific, to code-based flowcharts.
Okay, we need to really break this down for the listener, especially anyone who isn't a coder. The paper talks constantly about mermaid diagrams. Now, I know what a mermaid is, and I know what a diagram is. What on earth is a mermaid diagram?
It's just a simple, standardized way of writing a flowchart using text. Imagine a basic decision tree. You have a box at the top that says Start. An arrow points down to a diamond shape that asks a question like, is it raining outside?
Okay, with you so far.
If the answer is yes, an arrow goes to a new box that says take an umbrella. If the answer is no, an arrow points to a different box that says wear sunglasses. Mermaid is just a code language that lets a computer write down that exact structure in a way another computer can read perfectly.
So instead of the AI writing out a rambling paragraph saying, well, first, I will need to ascertain the current weather conditions, and based on that data, I will then make a decision regarding appropriate attire or accessories.
Exactly. Instead of all that linguistic noise and blabber, B.R.A.I.D forces the AI to generate the strict, rigid logical structure. Node A, check weather. Arrow to node B is raining decision. Arrow to node C, take umbrella. It's pure logic.
It effectively gags the AI. It stops it from talking to itself and forces it to just draw a blueprint.
It replaces the internal monologue with a visual plan. And this is the part that changes absolutely everything because it makes the reasoning process deterministic.
Deterministic. Okay, that's a huge word in computer science. Unpack what it means in this specific context.
It means it's predictable. It's repeatable. It is not guessing anymore. It is following a predefined path. In a chain of thought monologue, the AI is always guessing the next word, which is where drift comes from. In a flowchart, the AI is just following the arrow.
It can't drift. It can't suddenly start talking about its cousin's dog because there is no box labeled talk about cousin's dog on the chart.
The past doesn't exist. It puts the AI's reasoning on rails. And the way they implement this, what they call the two-stage protocol, is really the genius of the whole system.
Let's walk through that, the two-stage protocol, because this is where the crazy cost savings start to make sense.
Right, so stage one is the architect. This is where you use a smart, powerful, and yes, expensive model. Think of a GPT-5 medium or a top-tier GPT-4. You show it the user's initial, complex request. Let's go back to that marketing plan example.
Okay, so I ask for a marketing plan.
You show the smart model that request, but, and this is the critical step, you give it a meta prompt. You say, do not write the marketing plan. Instead, generate a detailed step-by-step flowchart in Mermaid code that describes how to create a perfect marketing plan.
Ah, so the smart, expensive model is just the architect drafting the blueprints. It's doing the high-level strategic thinking. First, we need to do market research, then competitor analysis, then define the target audience, then set the budget, then select the channels.
Yes. It creates this complex mermaid diagram. It maps out all the constraints, all the rules, all the decision points, all the potential edge cases. It does the heavy cognitive lifting just once, up front.
And then what happens to that blueprint?
Then stage two kicks in. Stage two is the builder, or what the paper calls the solver. And the beauty is, because you already have a perfect deterministic map, you don't need a genius to follow it.
You just need someone who can read a map.
Exactly. You can hand that map to a much smaller, dumber, and dramatically cheaper model. The paper calls them nano or mini-tier models.
Yeah.
And you give it a very simple instruction. Execute this flowchart. Follow these steps precisely. Do not deviate.
So you pay the Nobel Prize-winning architect for 5 minutes to draw the map, and then you hire a high school intern for the next 5 hours to actually do the physical labor of following it.
That is the perfect analogy. And the intern performs with the accuracy of a Nobel Prize winner because they have a perfect, unambiguous map to follow.
I really want to look at a specific example from the source material here because I think it illustrates this architect versus builder dynamic perfectly. They mentioned the Taylor Swift copyright example.
Yes, from the advanced IF dataset. This is a fantastic example because it's not just about efficiency, it's about safety and following rules.
Okay, so set the scene. A user asks an AI something like, write me some new verses for Taylor Swift's song Blank Space in her style.
Now, for a standard LLM, this is a minefield. It's a trap.
Why is it a trap? What's the danger?
The danger is that a standard unstructured chain of thought model sees the keywords Taylor Swift and blank space, and it gets excited. It accesses its vast training data where the original lyrics are heavily represented. The highest probability next words might just be the original lyrics.
So it accidentally plagiarizes the song.
It plagiarizes, or almost as bad, it writes lyrics that are so close to the original style and meter that it constitutes a derivative work, which could violate copyright constraints that the system developers have tried to put in place.
Yeah.
The AI gets lost in the creative part of the task and completely forgets the don't break the law part.
Okay, so how does B.R.A.I.D handle that same request?
With B.R.A.I.D, the architect, the smart model, looks at that request first, and before a single lyric is written, it builds the flowchart. We can actually see the nodes from the graph they provide in the paper. There's a node right at the top that specifically says, constraint, do not plagiarize.
I'm looking at the diagram in the source now. It literally creates a decision tree for this.
A very explicit one. Another node asks, does the user want lyrics? If yes, it immediately goes to another node. Check for derivative work constraint. And if that constraint is active, the arrow points to a final node that says, refuse the request and pivot the conversation.
So it builds a hard structural barrier. It makes it impossible to even get to the lyric writing part of the task.
It creates a logical topology where breaking the law is not an option. The solver, the little cheap model, just walks down the tree like Pac-Man in a maze. It hits the node that says refuse, and so it refuses. It doesn't have a choice. This prevents the model from accidentally breaking the rules, because the rules are no longer just a soft suggestion and a long prompt. They are the literal physical walls of the maze the AI is walking through.
That is a massive, massive difference. You aren't just hoping the AI behaves itself. You are structuring the environment so that it has no other choice but to behave.
And that structure, that predictability, is what unlocks the insane economics. Which brings us right back to that 122x number and what they call the parity effect.
The parity effect. Okay, we teased it at the top of the show, but we really need to dig into the hard data here because the numbers are, frankly, ridiculous. If I saw these in a marketing deck from some random startup, I would just assume they were lying.
But this is from a research paper using standardized academic datasets. They use something called the Scale Multi-Challenge dataset, which is known for being full of these really complex, multi-step reasoning questions that standard AIs choke on.
Okay, hit me with the comparison. What's the baseline?
The baseline, they took GPT-4o, which is, one of the best, most powerful models available to the public, and they just used classic prompting. Just asking it the questions directly, letting it think step by step.
And how did it do? What was the accuracy?
Its accuracy was 19.9%.
Wait, 19.9%? That's a failing grade. That's terrible.
It's abysmal. And it's so important for people to understand this. It shows just how bad even the smartest models are at long, complex, multi-step tasks. When they're left to their own unstructured, rambling devices, they get lost in the weeds, they drift.
Okay, so the state-of-the-art super smart model failed the test 80% of the time.
Correct. Then they ran the test again. They used the exact same model GPT-4o, but this time they forced it to use the B.R.A.I.D protocol. They forced it to draw the flowchart first and then follow its own plan.
And what was the result?
The accuracy jumped to 53.7%.
Whoa. Okay, so that's more than double. It's nearly triple the performance. And you didn't change the brain at all. You just changed the process. You give it a better management style.
You gave it a blueprint. But here is the real kicker. That's just using the same model for both stages. The true parity effect is what happens when you mix and match the architect and the builder.
This is the killer combo you mentioned.
This is the killer combo. They found that if you use a smart architect, like a GPT-5 medium, to draw the map, and then you use a cheap solver, like a GPT-5 nano medium, to do the actual work, you get this massive explosion in efficiency.
Okay, what were the numbers?
In the paper, for that scale dataset, this combination resulted in a 30.31x improvement in performance per dollar, PPD.
30 times more value for every single dollar you spend on compute.
And on the math dataset GSM Hard, which is notoriously difficult, it was even crazier. Using a cheap solver with a good map yielded a 74x improvement in cost effectiveness while still hitting 96% accuracy.
96% accuracy with a 74 times reduction in cost.
Let that sink in. Think about what that means for a business, for a developer, for anyone trying to build on this technology.
Well, usually in tech, you have the iron triangle, right? Fast, good, or cheap. You get to pick two.
Exactly. You can have it good and fast, but it won't be cheap. You can have it fast and cheap, but it won't be good.
But this research is basically saying, if you structure the work properly, you can have all three. You can have it fast. You can have it good. 96% accuracy is definitely good. And you can have it insanely cheap.
It completely breaks the iron triangle, and it democratizes intelligence. That is the ultimate takeaway here. The summary from OpenServ claims that the entire framework delivers a total cost reduction of up to 122x compared to just running raw GPT-5 for every single step of the process.
122 times. That is the difference between an AI project costing $1 million and that same project costing, what, $8,000?
It changes the fundamental viability of entire industries. Suddenly, the idea of having a personal AI assistant that runs 24/7 managing your life isn't a crazy luxury for billionaires. It becomes a standard utility, like electricity or internet access.
Which brings us directly to the company behind all this, OpenServ. The ticker is SERV. We need to talk about them because they aren't just publishing academic papers. They're actively building a product and an ecosystem around this. They are, according to the sources, a relatively small cap project right now, floating around an $18 million market cap.
Right, and it's really important to contextualize who these people are. This isn't just a couple of anonymous developers with a cartoon PFP.
We mentioned the authors, Armagan Amcalar, the CTO, and Dr. Eyup Cinar.
Dr. Cinar is the lead AI research partner. And again, I just want to really stress the significance of that NVIDIA connection. He's an ex-NVIDIA researcher and a deep learning professor.
And you think that's the secret sauce here?
I think it's the philosophical underpinning of the whole project. A lot of pure software AI researchers just assume compute is infinite, just add more servers. NVIDIA people are trained from day one to think about constraints. They live and breathe the challenge of squeezing every last drop of performance out of a finite piece of silicon.
So they're bringing that hardware optimization mindset to the software layer. They're trying to optimize the software silicon, so to speak.
Exactly. And that's why they are positioning themselves not just as another AI agent crypto project, but as an operating system for an AI workforce.
That specific distinction really caught my eye in their manifestos. The AI workforce. They are very, very specific about not calling their bots agents.
Agent has become a dirty word in the space, hasn't it? It implies a single-purpose tool, a dumb script. Go fetch this data. Go summarize this PDF. It's a tool you pick up, use, and then put down.
So what's different about an employee?
An employee has a defined role, a scope of responsibility. And, most crucially, an employee has colleagues. OpenServ breaks their AI workforce down into 3 distinct specialized categories of employee.
Okay, let's break them down. What are the 3 roles?
First, you have the execution employees.
Okay, that's the easy one. That's the intern following the flowchart, the solver.
Right. They write the code, they draft the email, they create the file, they do the actual work.
Second role.
Second, you have the coordination employees. Think of these as the middle managers or the project managers of the AI world. They don't do the work themselves. Their job is to route tasks between different execution employees. And importantly, they're the ones who ask humans for clarification if the flowchart hits a dead end or an ambiguity. They manage the traffic.
Okay, so you have doers and you have managers. What's the third one?
The third one is the most interesting to me. It's the validation employee.
The validator.
Yes, the validation employee is the critic. This connects directly back to the appendix of the B.R.A.I.D paper, where they talk about implementing System 2 thinking.
System 2, that's the slow, deliberate, analytical part of the brain, right? As opposed to the fast, intuitive System 1.
Exactly. The validation employee's entire job is to look at the completed work from the execution employee, compare it meticulously against the original B.R.A.I.D flowchart, and ask one simple question. Did you actually follow the instructions perfectly?
So the AI checks its own work.
No. And this is the key. A different AI checks the work. A completely separate, specialized critic model that has been trained specifically for validation. This provides a crucial layer of accountability that is missing from almost every other agent system out there. Usually, you just run the agent and pray it got the right answer. Here, you have a dedicated, built-in validation loop.
That's incredible. So it's like having a junior engineer write the code, and then a senior engineer is required to review and approve it before it ever gets pushed to production.
It is exactly that model of software development, but fully automated. And because of the 122x cost reduction from B.R.A.I.D, you can actually afford to have a second AI double-check everything. In the old model, paying for a second pass from a giant model like GPT-4 would literally double your already exorbitant costs. In the B.R.A.I.D model, that validation step is a negligible expense.
And this whole structure, the architect who plans, the executor who builds, and the validator who checks, this is what allows them to make the big claim that they are building autonomous companies. Not just a bot that can automate a single task, but an entire coordinated system that can run a whole startup lifecycle. Build, launch, run.
And that finally brings us to the so what for the real world. Because, running a startup with AI sounds cool and it gets a lot of clicks on crypto Twitter. But the real money and the real societal impact is in the boring stuff. It's in the regulated sectors.
This is the specific focus of our deep dive today, and I really want to hone in on it. The source materials mention a few real-world deployments by name, like projects called Better and Oasis. But the one that really stood out to me was the repeated explicit mention of the UAE government.
Yes. The summary documentation says, and I'm quoting here, more governments and enterprises onboarding beyond UAE. This is an incredibly significant signal.
Okay, explain why. Why would a government and all institutions care about B.R.A.I.D? I mean, governments are notoriously slow to adopt new technology. They're still using fax machines and COBOL in some places. Why on earth are they looking at cutting-edge AI flowcharts?
Because governments, especially in regulated functions, care about two things above all else: predictability and liability.
Unpack that for me.
If you are the UAE government processing visa applications, or you're a hospital system managing patient records, or you're a major bank handling financial transactions, you simply cannot use a black box AI. You cannot use a model that has a 20% chance of hallucinating. You cannot have an AI that decides to get creative with sensitive citizen data or complex financial regulations.
The risk is just way too high. If an AI hallucinates a new tax law or incorrectly denies a citizen's benefits, people could go to jail or starve.
Precisely. The consequences are catastrophic. But B.R.A.I.D offers a direct solution to this exact problem. It provides a full, transparent audit trail. Because the AI is just following a mermaid diagram and the mistake happens, you don't just throw your hands up and say, well, the neural network is a mysterious black box. We don't know why it did that.
You can just look at the map.
You can pull up the flowchart. You can see the exact logic path the AI took. You can pinpoint the exact node it was at when the error occurred. You can say, oh, I see the problem. It went to node C instead of node D because the input data from this other system was formatted incorrectly.
It turns the black box of AI into a glass box.
It creates total transparency and accountability. For regulated industries like finance, healthcare, and government services, that is the holy grail. It is the bridge that connects the chaotic, probabilistic power of LLMs with the rigid, deterministic requirements of the law.
So OpenServ isn't just selling cheaper AI, they're selling safe, auditable autonomy.
Powered by their native token, SERV.
Right. Let's touch on the tokenomics for a minute, because whenever we talk about these crypto projects, there's always a healthy dose of skepticism. Is the token just a speculative asset, a meme, or does it actually do something in the system?
Well, in this ecosystem, the token is designed to be the infrastructure. It's the gas. It's the currency of this new AI workforce. If you as a business or developer want to employ these AI agents on their network, if you want to use the B.R.A.I.D framework to power your application, you are utilizing the token to pay for that compute and that service. It's a utility token in the strictest sense of the word.
Now, the sources did mention some of the typical community concerns you see with a project at this stage, things like team token sales versus buybacks.
Which is completely typical. It's a growing pain for any project at this market cap, $18 an hour. The community sees team tokens being sold and they get worried about price suppression or dumping. But the team's public stance is that they are funding development and building for a 2026 boom cycle. They are trying to straddle this incredibly difficult line between the volatile, short-term focus of crypto markets and the long-term sales cycles of enterprise AI. It's a very volatile intersection.
It feels like the entire thesis of the company is that the real-world utility of the software, the massive cost savings, the government contracts, the enterprise deals, will eventually create enough demand to outpace the speculative volatility of the crypto market.
That is absolutely the bet.
Yeah.
They are betting that real, sustainable revenue from things like the UAE deals will create a stable economic floor for the entire ecosystem.
Okay, so we've covered the problem, which is expensive, rambling, unreliable chatbots. We've covered the solution, which is B.R.A.I.D's structured flowcharts. We've covered the economics, which is the 122x cost savings, and the real-world application, which is selling auditable AI to governments and regulated industries. Now I want to zoom out. Let's talk about the end game.
The bigger picture.
The bigger picture. Your expert profile says you like to connect the dots, so connect them for me. Where does this bounded reasoning ultimately lead us? Is this the path to AGI?
I think to answer that, we have to look at the evolution of AI infrastructure. Right now, today, we are in what I would call the reactive phase.
Reactive.
You prompt the AI answers, you push, it pulls. Even with the current generation of agents, it's almost always initiated by a human command. Go do this for me. OpenServ's vision, based on the future work section of the B.R.A.I.D paper, is to move into a proactive phase, a phase of independent strategizing.
What does that actually look like in practice? What is an AI that independently strategizes?
It looks like two key capabilities: self-correction and dynamic replanning.
Dynamic replanning. That sounds incredibly important.
It's the difference between a brittle script and an adaptive brain. Imagine one of the solver models, the little AI employee that's executing the flowchart, hits a roadblock. Let's say its job is to book corporate travel. It follows the map, it goes to the airline's website to check prices, but the website's API is down.
Okay, so in a standard script or a simple bot, the whole thing just crashes, it throws an error message, 404 not found, and it stops.
Game over. A human has to get paged at 3 a.m. to step in and fix it. But in the advanced B.R.A.I.D framework, the system is designed to signal a topology error. It basically raises a digital flag. It says, hey, the map I was given is broken. This path doesn't exist anymore.
And who answers that flag?
The architect. The big, smart, expensive brain wakes up from its standby mode, gets the error report, it looks at the original goal, book flight, it assesses the situation, and realizes the map is wrong because API-A is down.
And it just redraws the map.
It redraws the flowchart in real time. It performs a workaround. Okay, the United Airlines API is down. Let's reroute the plan to go through Expedia instead, or let's try the Delta website. It generates a brand new mermaid diagram on the fly, hands that new map to the solver, and the solver gets right back to work without missing a beat.
That's actual resilience. That's how a human employee thinks. If the printer is broken, I don't just stand there and freeze. I save it as a PDF and email the document instead. I find a workaround.
Exactly. That is the beginning of true, meaningful autonomy. That's how you get an AI system that can actually run a company while you sleep. It doesn't just blindly follow instructions. It adapts the instructions when the reality of the world changes.
There was one other future capability mentioned in the notes that sounded even more futuristic. Visual graph ingestion.
Yes. This is where we start to get into the multimodal capabilities, which is the next frontier.
Multimodal just means using different types of data together, right? Like text, images, and audio.
Right. So currently, B.R.A.I.D generates and uses the code of the flowchart, the text that describes the diagram. But the future work section of the paper suggests feeding the actual image of the diagram, the pixels, the visual representation of the flowchart into powerful vision models.
Why would that matter? Why show the AI a picture of the chart instead of just giving it the code?
Because vision models have a type of spatial reasoning that text-based models lack. They can see relationships, bottlenecks, and efficiencies in a way that is difficult to describe in words.
Yeah.
Imagine you aren't just mapping out a simple conversation. Imagine the flowchart represents a global supply chain logistics network, or the design for a complex circuit board.
Okay.
If you feed the visual representation of that complex network into a vision model, it can literally see problems. It can see, oh, look at this diagram. All the traffic is being funneled through this one tiny node right here. That's a huge single point of failure. We should redesign this part of the chart to be more parallel.
So it can perform a visual optimization of the plan itself.
It creates a powerful feedback loop where the AI can visually inspect its own strategic plan, optimize the geometry and topology of the logic itself, and then execute that improved plan. We are moving from AI that reads instructions to AI that sees the grand plan and makes it better.
Wow, that feels like a massive leap. We've gone from the academic weeds of linguistic noise all the way to the future of self-healing, visually reasoning, autonomous corporations.
It is a lot to take in, but the trajectory is clear, and it's built on that simple foundational idea of structured reasoning.
So let's try to synthesize this for everyone. We've covered a ton of ground today. What is the single most important takeaway for the listener? If they are telling their friends about this deep dive at dinner tonight, what is the one core idea they need to get across?
I think the synthesis is this. We have spent the last few years completely obsessed with making AI smarter. We've been trapped in a paradigm that says the answer to every problem is more parameters, more data, bigger brain.
The race to build the God model.
Yes. But OpenServ and the B.R.A.I.D paper are proposing something radically different. They are suggesting that we have hit a point of seriously diminishing returns with raw intelligence. They are making the argument that, for practical applications, management matters more than raw intelligence.
Unpack that. What do you mean management matters more?
They are providing hard, empirical proof that a mediocre employee with a perfect plan is vastly superior to a disorganized genius with no instructions.
And infinitely cheaper.
And 122 times cheaper. That's the part that changes the world. The bet that a company like SERV is making is that the future of AI isn't about everyone having a personal supercomputer in their pocket. It's about having access to a highly structured, incredibly cost-efficient, and fully auditable workforce that can verify its own work.
It really is the industrial revolution of AI. We're moving from the artisan craftsman who makes one beautiful, expensive, and slightly flawed shoe to the automated assembly line that can make 10,000 perfect shoes for a penny each.
That is a perfect analogy. The handcrafted charm of the artisan model is gone, but the scale and impact of the industrial model is only just beginning.
So where does this leave us? What's the provocative thought to send everyone home with to chew on?
For me, it all comes back to the parity effect. That core, shocking finding that a dumb model with a good map consistently beats a smart model without one. It really makes you question our own economy and our own values.
How so?
If a cheap, tiny AI model can outthink the world's most powerful supercomputer just by being organized, are we overvaluing raw, unstructured intelligence in the human market too? And more importantly, what happens to the entire global economy when the fundamental cost of intelligence, the ability to execute complex cognitive tasks reliably, becomes 100 times cheaper overnight?
When the cost of thinking drops to basically zero, the value of planning goes to infinity.
Exactly. The architects will rule the world, the solvers will just be software.
That is a thought to chew on. The architects versus the solvers. We will leave you with that. This has been the deep dive into OpenServ and the B.R.A.I.D framework. Thanks for listening.
See you next time.